Alright, so far everything in our class that you guys have seen related to and we've worked through has focused on the two subatomic particles of protons and of the neutrons. Today we're going to flip, and from here on out in this class you're going to feel like we're really focusing more on the electron. And it's true, because remember that electron, and what it does is that electron is used within bonding, gives properties. There's so many things that's involved with that. We're not going to leave the neutrons and the protons behind. Like I told you, everything in this class links together, and it's still going to link together. But in this today, we're going to start on something focusing within those electrons, and what they are called is electron configurations. Typically we get to this point and students get really excited, and I understand why you get excited, because what you'll see here is this pretty much has a pattern to it. I teach you the pattern, you follow the pattern, and you'll rock and roll. You'll do great. Okay? With other things that we've learned previously before, it's hard, it's difficult, and can be confusing. You got to know when to use what part. In this, it's not that bad. So the first thing I want to talk about, there's three different types. Okay, so three types of these electron configurations. Within this, they are very special, and they all serve a specific purpose for us. And we'll get more in detail with it here in a little bit. And whenever I'm showing you some things in this part, you're just going to have to accept some information I'm giving you, because this is mixed in with the next lesson you're going to learn about. And the best thing for you to do is just accept this for now, and then just rock and roll with it. So in this, in our three types, the first one we have is orbital notation. This is probably my most hated one, because it's the most long and drawn out one, and the reason behind it is what orbital notation is. Orbital notation is a form of electron configuration showing the orbitals. For anybody who has a heart attack, I know you don't know what an orbital is right now. That's one of those things I'm saying, just accept it, okay? So showing the orbital with arrows to show electrons within them. I know this can be confusing, okay, and I haven't taught you how to do this. It's coming up in this lesson, in this video, a little bit of how to do these, but whenever you're looking at these, this orbital notation, I just want to show you an example of what one of those will look like. Okay, so I'm going to show you one for sodium. So I'm going to do it in green. So here's sodium, and this is what I'm talking about. It shows the orbital. So here's like the orbitals I'm talking about. First thing is there's going to be a dash, and just an empty space like this, just a line. And below it, we label what the orbital is. So in this case, the first one we always see is a 1s. Now this 1, I'll go on and tell you, that 1, that number that you're going to see with these, that's referring to the energy level that that electron is in. And that letter, there's 4 different letters we're going to deal with, S, P, D, and F. Those letters are telling you the shape. So it's telling you the shape of it. And the empty spaces up here, which you'll see as we go through, S has 1, P has 3, D has 5, and F has 7. Those empty spaces are the orientation of those orbitals, and you'll see like what I'm talking about later on, but it's kind of like in X and Y plane. So everybody knows that the X axis goes like this, the Y axis goes like this, and that's pretty much what we're looking at, is what those blanks are representing. We'll end up representing those with numbers though to make our life a lot simpler. So we got 1s, then we'll go to 2s, then we go to 2p, and I know you don't know this yet, but you're going to catch on. 2p, like I said, p has 3, so we put 3 dashes, and you always go in the middle, okay? Always go in the middle of those to label out the energy level and the actual subshell shape. So this will be 2p. Excuse me. There's 2p, okay? Now there's 3 there for 2p, so 2p goes right in the middle right there. After 2p, we got one more, which is 3s. Now here's the thing, is in this, like I said before, the key to this is what we're focused on, the electrons. And within this, we do this orbital notation, it does these blanks like this, and it has arrows to show the electrons. Now within this, there is something important to know. Your arrows have to, if they're in the same orbital, it has to point in different directions. So what I'm saying is, in one case, your first arrow will always start up, and then your second arrow will always go down whenever it's going in that orbital. We'll go through these rules in a little bit, okay? Don't freak out about it. But what you're going to see here is this right here, all this about is the spin of electrons. For you got to think, what's the charge in an electron? Negative. They're both negative. How can I have two things that are like charged sitting next to each other? You technically can't, but then what happens is this electron spins this way, clockwise, and this other electron will spin counterclockwise. What this does is the spin of that electrical force, it creates a magnetic attractive force between the two, which allows them to stay in here because it overcomes the same charge repulsive force. I know it's a lot there, that's why we're putting it in a video so you can watch it again. So this is probably how you're going to do your arrows. I'm going to show you how I like to do mine. Whenever I do my arrows, just because I don't know, it's some professor I had in college did it and I just like it and it makes me, I feel like I move faster through. I do halves. So I don't put the full arrow tip up. So I'm going to do the same thing here. That's what mine will look like. Either one is acceptable. It's whatever you want to do. The important thing I'm looking for, they point in opposite directions. Alright? So now, in this, let's fill in for sodium here. I know you haven't learned about this yet. Don't worry about it. It'll be okay. So in this, first thing we have is we go through the 1s. So I have 2 up, 1 down. Go through 2s, 1 up, 1 down. I go all the way through 2p. This is where I'm going to introduce another rule to you. We'll define it here in a little bit, but I want you to see this at first. So what this is called Hund's rule, but we actually look at it, I like to call it the empty seat rule. Okay? So let's say you get on a bus. Let's say school opens back up, we change the bus rotations, bus schedule, bus pickups, and you are being picked up on a bus with nobody you know. So here's my question. You know nobody on this bus. There's somebody in the first seat. Are you going to sit in the first seat with them, or are you going to go to the second seat? Now, for all those of you that want to be sarcastic and say, just to get Mr. Hall riled up, I'm going to say I'll go to the first seat. Whatever, let's say there is a creepy man sitting there that's giving you a creepy stare. You're not going to sit in that seat with him. You'll always go to the empty seat. And that's the same thing with electrons. They will go in the same energy level. They'll go into the empty orbital before they'll go into one that's filled. Okay? So the next electron will go here. And then just like that, the next electron will go here. Now here's the thing. Electrons are lazy. So these numbers, kind of look at them like staircases. The floor, the level of a building. So an electron has a choice now. Is it going to sit in one of these seats, or is it going to walk all the way upstairs? It's kind of like how some of you have been on the Zoom meetings. You know, are you going to get up and sit at a desk and look like you're attentive, or are you going to lay in your bed and be like, can he shut up so that I can get back to sleep? It's kind of like that kind of thing. What are you going to do? You're going to lay in your bed. Electrons are the same way. They're going to stay right here until this is full and no one else can go in there. Now we start with the down arrows. So here at this 2p we go down. Next one will go here. Next one will go here. And the fill order, it keeps going that way. It'll stay that way. Okay? We'll fill that 2p. Now we go to 3s. But we only have one in the 3s. So we put one up arrow and we're done. That is a proper orbital notation for sodium. Here's the key. Orbital notation. You got the blank spots for the arrows to go, and you have the energy level along with that shape of the orbital. Okay, so S, P, D, or F, you'll catch on that here in a little bit. So that is orbital notation. That was the first one. So now let's go into our second one. You're going to be like, wait, what? The second one, actual name is electron configuration. So an electron configuration. I know that's confusing because you said, Mr. Hall, all these are called electron configurations. It's the easiest way to explain it to you on this level. So all of these are electron configurations. So the second one is what we're truly going to look and say is an electron configuration. So in this one, this is a form of electron configuration. At which we remove the spaces and arrows from orbital notation and place exponents in its place. Okay? So pretty much what I'm saying we're going to do. We're going to do away with these spaces. So that space there is going to go away. This number and this letter will stay, and then what we'll do is take these electrons and we're going to put a number for them as an exponential value. So what I'm saying, just so you can get a feel for it and you can have one to compare by. So I'm going to do sodium here. I still have all those orbitals there. So I have one S, but here's the thing. How many electrons are in there? You see 2, so put an exponential value as a 2. So it's squared. Okay, I'm going to show you a pattern here in a minute how to get through that and work through it. Okay? In this, you just keep rolling. So you have 2s2, you have 2p6. Please notice that I'm not saying 1s squared, 2s squared, 2p to the power of 6. I'm saying 1s2, 2s2, 2p6, 3s1. Now I think you can automatically see why we like this one more than we like the orbital notation. How much quicker it is. Now, with this, we need to put, notice the difference here. These don't have the spaces. I can't stress this out enough to you. I'm absolutely known to ask kids to know the difference between certain terms and things in an application process. I'm not going to ask you to define it and give me a vocab word. I'm going to actually ask you to show me and work with them. I'll ask you the question, give me the electron configuration for barium. Give me the orbital notation configuration of iodine. Give me, well, you haven't learned the third one, but give me the noble gas configuration of krypton. Okay, I'll give them to you like that. So just for another practice example, this was to compare here so you can see the difference, but I want to do another practice example, and this will get me to where I can actually show you some things will open up for us. So let's do iron. That is atomic number 26 off your periodic table if you're looking for it. So within this, I'm going to show you here in a little bit, the way that I do it is I look at the periodic table. It's my map to success because you'll always be given a periodic table, so you can always use the periodic table. So that's how I'm looking at it. Like I'm looking over the camera at my periodic table right now, and I just start working through. We have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and this is why I did this one. This is where the subtle change comes in at. And you're going to see it more here in a second. I know it's a little confusing. I'm presenting this to you so it's in your mind, so whenever I explain it, it makes sense and it'll click. So in this, after you go to 4s2, you no longer go to the P first. You now go to the D, but you don't go to 4D. You see the pattern, how everything stays with the same number? It stays that way until we get to the D orbitals. So when we get to the D, it drops in energy level. So 3D, and I don't go all the way through the D, so I'm 1, 2, 3, 4, 5, 6 into the D. So 3D6. And that is iron. Alright? I know this may be confusing, just stick with me. Just keep writing it down. You guys will get this. I believe in you. Alright, now the third one. This will probably be your favorite one because this is the shortest one. This is the shortcut. This is the one that you'll love. As much as that was a short, electron configurations is a shortcut from orbital notation, these things take K. Number 3, noble gas configuration. Uses the chemical symbol for a noble gas, well, for the last crossed noble gas to substitute in to shorten the electron configuration. I'm going to abbreviate as electron config. So this is kind of like in math class. In your algebra class, you guys should have learned substitution method. I'm pretty sure they typically use U. That's what I learned. They'll say U is equal to blah. And then they'll throw U in where that was in at the problem. And they'll use it, and it breaks it down, and it makes it simpler for them to try and figure something out. So in this is the same thing you're going to do. So I'll show this to you here in a second, but iron, for example, when I look at iron, I look at the last crossed noble gas we went over. The easiest way to do that is take your finger on your periodic table, put it on iron, then you're going to move up one row. So we're going from 4th row, 3rd row. Then you go all the way to the end to the 18th column. It's the very last one on the end of the periodic table. Whenever you go there to the end of the periodic table, what you will be at is the noble gases. The 18th column is the noble gases. They're very special. We'll talk more about them later on. But with this, whenever you do that, you go up one all the way to the end, you'll see that it's argon. So I'm going to do argon electron configuration. Okay, I'm not doing the noble gas configuration right now. I'm doing argon's electron configuration. And I'm doing that to show you something here. Showing you how this is a shortcut and how this works. So what you're going to do first, 1s2, 2s2, 2p6, 3s2, 3p6. We're done. That's argon. Alright, now, I did it really quick. I just did it. I'm just presenting this stuff to you right now. Okay? We'll work some practice problems later. Get you used to it. Now in this case, do you see a similarity between iron and the argon? This is the part where you said yes, and you told me that this right here is the same. And that's very true. What's the difference is the 4s2 and the 3d6. So now in this case, I'm going to do the noble gas configuration for iron. So for iron, here's the key. You take the chemical symbol and put it in square brackets. Okay? What I'm saying, put it in square brackets like this. Do not put it in parentheses. If you put it in parentheses, you are wrong. I'm not stressing this enough. Square brackets. You must use the square brackets. Now the fact that we have this here, that substitutes in for this. It changes our starting point, and I'll show it to you here in a minute what I'm talking about. But in this, it now changes our starting point. Now what we're looking at, we're starting here. So the only thing we have to add is go from there. So 4s2, 3d6. Bad 6. How fast was that? That's what I'm talking about. These things will move super quick for you, okay? These are the 3 different types. You need to make sure you know the difference in the 3 different types. The first one is the orbital notation, super important. Second one, electron configuration, stretches it out, puts the number of electrons as exponents. Third one, noble gas configuration. It puts the chemical symbol of the last cross, noble gas, in the square brackets, and then you start from there, and it makes it a lot shorter. Please know the difference in the 3. If you have questions, ask me. Okay? From here, I want to deal with how you're going to find the pattern of the order. So how am I getting 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6? How am I getting that? I'm going to show you how to get it. So first I'm going to show you the way that I strongly dislike. I don't like it. I feel like it's confusing, but I still do it to help students out so that they can see it. Okay? So I'm going to erase a little bit here. I'm going to leave these over here on the right. This is what you got to do. Energy levels in this case, they range from 1 to 7. Certain ones fill at certain places. So the first thing we got, let me turn my chair around. So you start making columns with these. And you're going to start with S. And S goes from 1 to 7. So we go 1S, 2S, 3S, 4S, 5S, 6S, 7S. Now you do P. Now P starts at 2. And P is like 7S. It'll go all the way through. Okay? From 2 to 7. So in this case we have 2P. Or not 2P, that is the question. I'm just kidding. 3P. 4P. 5P. 6P, 7P. Now you're starting to see why I don't like this one so much, because you have to keep this in mind. It's not as bad though, I guess. In this case, you go now to D. We're going to make a D column. The D column doesn't start at 2, the D column starts at 3. So 3D, 4D, 5D, and it ends at 6, so 6D. Now we go to F. F starts at 4, and there's only a 4F and a 5F. So this is what you're looking at. This is what you have to be able to do first. If you choose this option, this is option 1 to get your fill order. There's 3 options. I got a feeling you'll choose option 1 or option 3. So in this case, now what you do is you start going from right to left, and we're just going to draw arrows through. This is another reason why I don't like this. If you mess one of these columns up, your arrows will be messed up. If you mess your arrows up, you've messed up. There's nothing that can be done. So in this case, let's start. 1S. This is how the arrows will go. I'm going to put the fill order up here. So we go 1S. I'm actually going to put the exponential value to it. I'll show you here in a little bit how you get this. So 1S2. Then we go from 1S. We draw arrow. We go through 2S. So 2S2. Now we come over here, draw again. 2P and 3S. So it's 2P6, 3S2. Do it again. So then we'll get 3P6 and 4S2. I'm going to step over. Just dawned on me I may be blocking your view. So we went here, then here, then here, then here. Now, again, going right here. So 3D, 4P, 5S. Okay, I'm literally just taking the last. I'm literally just taking that last high number. Okay? So in this case, 3D10, 4P6, 5S2. Then from there, we're going to go to the 4D, 5P, 6S, so 4D, 10, 5p6, 6s2. Then we're going to go 4f, 5d, 6p, 7s. I think you're starting to see why this is not my favorite method. I don't enjoy this, but if it works for you, use it. But if it doesn't, don't try it. Choose the one that works for you. So 4f, 14, 5d, 10, 6p, 6. I bet y'all miss that bell, don't you? I still hate that stupid bell. 6p, 6, and 7s2. Then we finish off with 5f, 6d, 7p. That did not even do right. 5f, 6d, 7p. So then we go to 5f, 14, 6d, 10, and 7p, 6. I don't know if you can see your fill order up there, but that's your fill order. Okay? So this is a method you can use to get this. I call this the Christmas tree of Christmas. Not really, but it just feels that way because I use red. So in this is your fill order you'll get. Fill order will be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, 4f14, 5d10, 6p6, 7s2, 5f14, 6d10, 7p6. And that's another way if you just want to memorize it. I don't recommend it. Okay? If you need to, go back, make sure we have that same fill order. You have to have that exact fill order. Okay? So now what I want to do, I'm going to jump over to the periodic table and I'm going to show you how I like to do things and how it works for me. And I'm going to tell you why. A little bit of extra stuff over there. Because when you're looking at this, you look at the S, you look at P, look at D, look at F. How many dashes, I'm going to call these dashes, does an S orbital get? It gets 1. Well, subshell. 1. How many dashes does a P subshell get? 3. 1, 2, 3. D subshell gets 5. 1, 2, 3, 4, 5. F gets 7. 1, 2, 3, 4, 5, 6, 7. So in this case, remember, when we're talking number of dashes, how many do they get? S gets 1, P gets 3, D gets 5, F gets 7. Okay? That has to stick in your mind. The reason I show you that is how many of these there are is look at that number and multiply it by 2 and it tells you the number of electrons that can go in that subshell. So how many electrons can go into an S subshell? 2. So it can have 2 electrons. Why can it have 2? There's a simple way to look at it. How many can go per dash? Only 2 electrons per dash. How do I know that? How many arrows can go in that dash? 1 can go up, 1 can go down. That's it. So that's one other way of looking at it. What about P? How many electrons can a P subshell have? 2 ways of doing this. There's 3 dashes. Every one can have 2, so you get 6. 6 electrons, or you can look and say they go 1, 2, 3, 4, 5, 6. You'll find the same thing here for the D. Will be 10 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. F subshell can have 14 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 of those electrons can go in that subshell. Okay, so I'm pretty sure this video has been going for a while. What I'm going to do, I want to jump over to the periodic table, and I want to take and show you my method on the periodic table of how to figure these things out and get these things to make some sense. And then I think what we'll do on the next video is I'll explain those rules I was talking about, and then we'll actually work through some examples. I feel like that'll be good. So I'm going to go over to the view board, rock and roll with the periodic table. Alright guys, so like I was saying, here on this periodic table, what we're going to look at, okay, I got to zoom it out some so we can see the whole periodic table. Okay, so first thing I want to do is I want to show you some important information on here and how we get certain things. So first off, there's special areas on this periodic table. I'm going to start referring to them now. You're going to hear it as S block, P block, D block, F block. Okay, know it sounds like prison, but it's not. So in this, I want to show you where these things are and how they break down. And this is where I told you this is my method I like to use to get this fill order. So I got to give you all this information off this periodic table so you can see it. This is the same periodic table we've been using in class. So if you're looking for it, it's the same exact thing. I can send you the file if you want. And this is what I use. Whenever you guys come back in class, I'll probably like stack you up with 4 of them, just because you ain't been here for a while and I ain't gave you any. So in this is what we're looking at. So the first one is knowing these columns. These numbers up here are these columns numbers. It goes 1 to 18. And in this, what you're going to see is I'm going to break it down in columns. So the first thing we got, columns 1 and columns 2, okay? That is the S block. So right here, so columns 1 and columns 2, this is the S block. Alright, this is every time when we look at it where we're looking and saying this is S. Alright, that's what we're looking and saying, that's what we're seeing, that's what we're getting. Then you break outside of that, hold on, before I forget. This is one case. Helium's over here because it acts as a noble gas. But before I forget, helium in this case, imagine helium over here setting with hydrogen, okay? This is the time that if you look and you say helium has moved. Now outside of that, that's the S block, alright? Now I'm going to take you to the second one, P block. P block is columns 13 through 18 in this area right here. Realize I did not really include helium into that because helium is over here. This is P block. Alright? So columns 13 through 18 is P block excluding helium. And columns 1 and 2 including helium is S block. Then we're going to have our D block. Okay, these are our transition metals. These guys are right here, columns 3 through 12. This is D block. And if you're wondering what this S is, this P is, this D, those I keep saying orbitals, I keep saying subshells, that's all going to be defined for you in the next lesson. This is the stuff I was talking about, just assume it and accept it. Not assume, but accept. That's what I meant. So columns 3 to 12 is the D block. That's what we're getting here. Then outside of this, what you'll see, down here at the bottom where this says lanthanides and actinides, that is the F block. Okay? So, I'm trying to figure out what color would be good. I guess I might have to go black. Black with a squiggly line. This is the F block. Now here's the thing with these whenever you're looking at it, okay? this lanthanides here, these guys fit actually right here in this periodic table. That's truly where they should go. And whenever you look here, the actinides, this down here, they should fit right there actually. But if we do that, it makes the periodic table look weird. So what we do is we put placeholders there, drop it down. The easiest way to see that is notice we go from barium 56 to lutetium is 71. That's a gap. You're like, why is that gap? Because 57's down here, lanthanum. Okay? So you'll drop down here whenever you go through. Now I want to show you the fill order and how I get this fill order. Alright? This is my method. I use this as a roadmap. This is literally what I do with it. I start driving until I get there. And then I stop. So this is what I'm looking and saying. Every time you're going to start somewhere, this is what I'll do. So remember sodium, okay? You should have it on a piece of paper right now, but I have it over on the board behind the camera now. Sodium. I find where sodium is on the periodic table. That is my stopping point. Here's why I showed you what I did. Where is sodium at? Is it S block, P block, D block, or F block? Hopefully you said S block. So it's in the S block. Now what row is it in? 1, 2, 3, 4, 5, 6, 7. Those are the rows. We're in row 3. I will stop at 3S. How far in did you go into the 3S? I went one place. 1, 2. So it has 1 electron, or 3S1. Here's what I do to get this. I literally start. I start here at hydrogen, and I go through, and I go all the way through helium. So what was that I just went through? First row, S block, 1S, and I went all the way through it, so it's 1S2. You look at those boxes as the electron. There's your first electron, second electron. Look at the second one. Okay, let's go here. We're going to keep going because we have not reached this stopping point yet. So I go through lithium and beryllium. I went all the way through. What row is that? Second row. S block. How far? All the way. 1, 2 to S2. Then we go to the P block. Now the P block keeps the same pattern. It takes the number of the row, that's the energy level. So we're still in the second row. So 2P, because second row, and I go through the P block, I still haven't reached my stopping point, so I went all the way through it. So how many electrons are here? There's 1, 2, 3, 4, 5, 6. So I get 2P6. Now in this, I come down again. Boom, I hit my stopping point. So I stopped here, but I went into the third row in the S block, so it's 3S. I went 1 in. I didn't go all the way through. See where we didn't go through magnesium there? So it's only 3S1. Which you should get. Sorry there, I didn't mean to ignore that mark. So you should see that that right there is the electron configuration for sodium. 1s2, 2s2, 2p6, 3s1. And it's the same thing we got over there on the board. This is how I'm figuring these things out. This is how I do it. Alright? That shows you how I travel through. I want to show you the fill order I get. You need to have the fill order down on the paper because I don't have anywhere room on here to where I can write this fill order out. So I'm going to work through it. I'm going to zoom it out a little more. Alright, you always start here at hydrogen unless you do a noble gas configuration, then you change your starting point. So we go 1s, because I'm in the first row, I'm going through the S. 1s all the way through, that's 1s2. I go second row, I'm in this S block, so it's 2s2. Then I go second row P block, so it's 2p. I go all the way through, it's 6. Then I go here to 3s2. Then I go here to 3p6. Okay, you should see that the fill order is staying the same. 3p6, 4s2. Fourth row, S block, all the way through. Done. Now it changes. S and P will keep the row for the energy level. But here's where the change comes. For D, N, which is energy level, okay, is equal to the row minus 1. Remember, N is energy level. So in this case, when we look here, I just went from 4s2. Now I come into the D block. What do? I'm in the D block, I automatically go to my row. I'm in the fourth row. 4 minus 1 gives me 3. So it's 3D. There's 3D, and I go all the way through. So it's 3D10. Now once I get through the 3D, I go back to P. Remember, P is equal to the row, so it's 4p6. I come back down here, 4p6, I come down to the fifth row, and I'm here at the S block, so it's 5s2. Now I go back in the D block again. So now what do we got to do? There's a change. What are we doing here? With this change, we have in the D block, we take the row, which is 5. So 5 minus 1 is 4. It's 4D. I go all the way through 4D10. Then I go into the P block. So it keeps the same as the row. So it's 5P6. Then I come back down to the 6th row and I start in the S block. So 6S2. Alright, I'm going to pause there. So hopefully you're good. We should have 1S2, 2S2, 2P6, 3S2, 3P6, 4S2, 3D10, 4P6, 5S2, 4D10, 5P6, and 6S2. Now we're not done, but I stopped and paused because of the big jump here. This is why I say use the periodic table. So many kids, when they use the other method, they will forget you're going to the F's. But look right here. This is really down here. So everything changes. Now, what you get here is something like the D block. So whenever you're looking at the F block, N for energy level is equal to the row minus 2. Okay? So N equals row minus 2. So we'll come down here. What row is this? Don't look at this as it goes 7, 8, 9. No, remember, this fits in here. So this really is the 6th row. You're still in the 6th row. So 6 minus 2 is 4. So then we go 4F and we go all the way through it. Now once you get there, you will then come back up and go back into the D block. So then we'll go 6S2, 4F14, then I go back into the D block. Remember, when you get into the D block, row minus 1. So 6, still in the 6th row, minus 1 equals 5. So it's 5D, go all the way through. 5, excuse me, I keep swallowing spit. 5D10. Then we're going to break in back into the P. P, you have the row is equal, the energy level, the number is equal to the row. So 6P6. Then we jump back down here to the 7th row. The 7th row is, you guessed it, 7S2. Then we change it from there. And remember, we go from 88 to 89. This actually is here. It's down here at those actinides, okay? So we jump down, and once we jump down, remember you're now in the F block. What row is this? You should have that as the 7th row. That is awful of me. That's supposed to be 7th. Okay, I know that looks horrible. That's supposed to be 7th. This is the 7th row. So what do? N equals row minus 2. So 7 minus 2 gives me 5. 5F. We go all the way through, but remember, you got to come back up. 5F14. So 7S2, 5F14. Then we go back into the D block. We get back into our D block. Here at the D block, it's row minus 1, so 7 minus 1 is 6. 6D, 10. Then we're going to go into the P block, and it's row equal, the number is equal to the row. So that is, boom, 7P6. That's how I figure these things out, looking at this periodic table, okay? So, give you a second there. This is a video, so if you need to, pause this. I'm just going to keep moving. In this, I will look at you and tell you, with these, I know that may have been confusing, where I'm getting that number from. So I'm going to do it here. So S, P, D, F. The important thing is to remember N equals energy level. Okay, N is that number, that 1S. That 1 is N. That's what I'm talking about. So for S and P, N is equal to rho. I can't stress that enough. This will come back into play in the next lesson. We're going to do the reverse. So N is equal to rho, but look at D, okay? D is where we get the change. N equals rho minus 1. That's for D block. Only for D block. Then when you get to F, F is N equals rho minus 2. That's how I'm getting that number for those. Alright? This is why I like this method so much more. And it's also very, very useful in the next lesson you'll be looking at. Hopefully this breakdown of this periodic table helps you. I know that was fast. I know you've never seen this before. Don't be scared to take this video, scrub it back, watch this again, work through this, guys. If you have questions, reach out to me on Remind. That's the best way for you chemistry students to get a hold of me. Have any questions, reach out to me. Alright? I do want to address, I almost forgot to address one thing. What I was talking about with that noble gas configuration, so whenever we did iron, so here is iron. This is what I'm telling you to do. take your finger, put it on iron, move up a row, and go all the way to the last column. That's how I got argon. Okay? Now a trick with this that Mr. Hall likes to use, I actually like to give you a noble gas. So if I gave you radon and asked for the noble gas configuration, you can't put radon in brackets. Okay? That doesn't work. You still have to follow the rule. Put your finger on it, move up a row, go all the way to the end. I'm at the end, so xenon. Okay? If you have any questions, please reach out to me. Besides that, probably just expect another video coming out. I think these videos like this, I think this helps a lot more because I think it's clear for you guys to see. My camera is a lot better quality than the camera on my laptop. If not, talk to me, give me some feedback. Hopefully you guys are doing good. Miss you guys like crazy. If y'all need something, let me know.